Here's an example of a density graph. So looking at this example here, here's some real data. The birth weights in California are normally distributed with a mean of 7.25 pounds and a standard deviation of 1.4. And so now we have data, this descriptive data, means and standard deviations. And so how is this helpful in analyzing and answering probability problems? Well, we're really converting these probability problems in many cases to what proportion or what relative frequency or what percent of the population fit a certain set of conditions. So here's the normal model or the normal curve, right, with the mean of 7.5, standard deviation of 1.4. So you can see how it's distributed across, right? These are the possible values. And then how often. Now, if it follows a normally distributed pattern, what we're looking at here then is this distribution looks like this. And then what we know is 68%, right, of all of the children who are born or will be between 6.1 and 8.9 pounds. And again, that's given from what we call the empirical rule. And that, again, came from this distribution here that we were talking about. This fits all normal curves. And so think about how could we use this data to estimate the percent of babies whose birth weights will be less than 6.1 pounds. How would I answer? How would you know that? Like someone says, what percent of children are born under 6.1 pounds? Well, how would we estimate that? Well, we would use this normal data. We know the mean and standard deviation. Here's 6.1 right here. And with that in mind here, you will see that I know 68% of the data is here. And so what we would do is, a way to think about it would be, I know then that those who are below 6.1 pounds are going to be all the children on this side of the curve, right? And so if I know this is 68%, what's left over out of 68% is 32%, right? So 1 minus 0.68 is equal to 0.32. And one thing about normal curves, they're symmetric. So if that's 68 there, then I know there is 16 on this side and 16 on this side. So technically this would be 16% would be our answer. But we're going to look at the tools to get that. That's how we would use this graph. So let's start with find the z-score for a baby with a birth weight of 6.1. Z-score is -1, going back to our z-scores. And so you'll see back to it, right, how we could use that right here. Here's your z equals -1. That's why it's this location here, mean -1 standard deviation. And then we can answer the question. But that's what we would need to do. Let's try this one. Find the probability that a baby in California has a birth weight of 6.1 and 8.9 pounds. So looking at that here, we will see there's your 6.1, there's your 8.9, and so the answer is 0.68 or 68%. But the probability, remember, is an answer efficient. It's like a relative frequency between 0 and 1. 95% of all California birth weights fall between what two values? Well, here's 95%, and so we see it's from 4.7 to 10.3. That's what we're looking at with the values. So it's between 4.7 pounds and 10.3 pounds is our answer there. And then we can continue on answering these questions. Find the probability that the baby has a birth weight between 4.7 and 7.5. So let's look at 4.7 right here and 7.5. It's a little bit harder to do, so you should pause and take a look at what percent that is. Right, what percent of the babies fall between 4.7 and 7.5? So notice my notation here, half of 95%. Where am I getting that from? Well, from here to here and from here to here is 95%. From 4.7 to 7.5, the answer is 47.5, half of 95, which is 47.5%, which I had to put here. 4.475 would be our answer there for that. And then what percentage of would fall relative frequency between 3.1 and 3.3 and 6.1, 3.3 here, and 6.1. So again, another kind of thing to have to think about. You might want to pause and try to figure that out before looking at the answer. I'll give you a second to pause, and then we go ahead and look here, and I got the answer of 16. 16 minus, actually it's going to be 16 minus 0.0, yeah, there it is there. And so your answer is 160 minus 15.145. There we go from there. And then the last one was the relative frequency of these other two here of greater than 10.3 pounds. Greater than 10.3 pounds is here. All of this is 95. And another important piece is to kind of recognize if this is 95 here, there's 2.5% left over here and 2.5% left over on this side, right? This is 95% of the population, and you have 5% left over, 2.5 on each side. So in that case there, we get 2.5% or 0.025, and the same thing for less than 4.7 is 2.5 right there.